Okay, so now that you've done some graphical addition of vectors and some simple vector addition with algebra stuff using components, let's do one that's a little more involved. If you haven't yet looked at it, you may want to go back and watch the video. I think it's called Formula Pack for Vector Addition. It's going to walk through this and ultimately give you a handy little set of formulas to look back at while you solve a problem like this. Have that handy while you do it. So here we go. I think the first thing here is when we're doing one of these problems or any kind of problem, what are our steps for doing it? So first is let's do a sketch just so we know what our resultant vector is going to look like roughly. That'll give us some check as to our correctness when we solve the problem. And then we're going to resolve those vectors into x and y components using those formulas that we have. And then we're going to re-add them, use our Pythagorean theorem to determine the magnitude of the resultant, and then find the direction of the vector using our inverse tangent rule. And then just double check it, and away we go from there. Now the first problem here is a little unusual in that you'll be able to figure out the resultant without doing the components. So don't use that as a crutch here, but use it sort of as a check for yourself. So the first thing I want to do, I want to sketch this thing. It's 30 newtons at 220 degrees. So I know that I'm going to go 180 and then another 40 gets me to 220, and that's 30 newtons. So I'm just going to write vector A is 30 newtons, 220 degrees. And vector B is 80 newtons at 40 degrees. Okay, so now, if I'm adding these things graphically, tail to tip, I start here, and I'm going to turn around, and I'm going to go back 40 degrees. Well, establish my new thing right here. This is 40 degrees. In this case, it's going to trace right back over it and go this way. Now, if you were doing another problem like this, for example, you might just need to get, hey, I've got a vector going at 220 degrees. So here's my starting spot. And then I'm going to have it going at 70 degrees. So I'd reestablish, do 70 degrees. And then I might have it going at something like 15 degrees. I'd reestablish and then do 15 degrees. And just know that ultimately my resultant gets me somewhere over there. That's all I really need to do with this. So while this one works out pretty slick, we're going to come back here. You can probably see that if this was 30 and this retraces it exactly, 80, 30 is going to cancel, and we're going to be left over with 50 newtons at 40 degrees. Well, you're a step ahead of the problem, but that still doesn't tell us how to do it. So let's go ahead and do the actual math and figure out what's going on here. Now, if I need to find the x component of my first vector, I'm just going to jump in and I'm going to use this thing to get the x component. I'm going to say x is equal to the cosine of theta times r. And for my y, it's going to be y equals sine theta times r. Because when we think cosine, we should be thinking x. When we think sine, we should be thinking y. So then I'll just go ahead and plug those into the calculator here. Cosine of 220 degrees times 30. In this calculator, it's going to be, so we can get the glare off of there. The cosine of 220 times 30 gives me negative 22.98. Now we're just going to go to the nearest Newton here. So I get negative 23. And just to save some space here, I'm going to go ahead and just punch this one in. So I'm going to go the sine of 220 times 30 gives me negative 19.28. So we're going to call that negative 19. And that checks out because I've got a negative x and a negative y. That's good. Okay. wasn't paying careful attention here and I skipped a box. So because there's only two vectors, we only need two boxes on this problem. We'll just go ahead and scratch this out. And let's get this one. X equals the cosine of 40 degrees times 80, and y is going to be equal to the sine of 40 degrees times 80. So now we're just plugging through these things. Cosine of 40 times 80 gives me 61.2 or 61.3. Again, we're just going to stay with whole numbers. So 61. And then the sine of 40 times 80 gives me 51.4. We'll do 51. Okay. Now I'm just going to add all my x components, negative 23 plus 61. 61 minus 23, I get 38. So the sum of all my x components is 38. Then I got 51 minus 19. Sum of all my y components is 32. So now, if I were just to sketch this thing, I really have one triangle where the x is 38 and the y is 32. And there's my angle. And this is going to be my resultant. Okay? So, Pythagorean theorem to determine the magnitude of the resultant. So let's go back. And here's that version that's already been rearranged. So we're just going to say the resultant equals the square root of x squared plus y squared. That's equal to the square root of 38 squared plus 32 squared. Okay. And I get 49.6. We're going to call that 50. And then finally, I'm supposed to use my inverse tangent rule. And I want to know what theta is. So the angle is going to be equal to the inverse tangent of y over x. I can go ahead and plug those numbers in. The inverse tangent of y, 32, over x, 38. So then we'll do the inverse tangent of 32 divided by 38. Close those parentheses, and I get 40 degrees. Again, always good to remember that you have your calculator in degrees, not in radians or some other measurement unit. And we get that our final vector is 50 newtons (40 degrees). And that makes sense because if we look over here, this looks like a good angle over here. 40 degrees, 50 newtons kind of matches up with what we thought. So that's your problem steps for breaking down a problem like that.